Okay, if anyone has any questions throughout the whole thing, you can just interrupt me too. But kind of like the outline for what we'll be doing, we'll look at like the formatting, like basic syntax, the memory, which is my favorite part because there are so many things I didn't know, and it makes so much sense why everyone's always confused. And then the like functions that we'll go over are kind of what Yang and Kenny told me to go over, and like what Calc 1 and Calc 2 will look at in their projects and stuff. So first we'll look at the functions. Also, you can follow along with like the thing that I emailed out too if you want. It might be nice to have that and like write notes and stuff. We'll start out with brackets. So the square brackets are arguments or inputs of functions. So like cosine, stuff like that. So you can do shift enter to do that and it should work. This stuff's pretty basic. So parentheses, basically just what we think of for parentheses. So it just groups expressions. And then the curly braces is used for like lists and plot range, and we'll see more examples of that also. And then another thing maybe to just mention, if we type in plot, we can find, run away. So we can look, oh my goodness, at the information. Let's see. Oh, there we go. So this is a lot of like, if a student's like, I don't know the syntax for this, I'm not sure exactly what to do, you can literally just press that little like I to learn more about a function. And then there's even like examples in here. So as you can see here, they can even like copy and paste that, but just make sure that it works. And then like having multiple functions, which we'll get into, but that's just a good thing to like troubleshoot if you don't know the syntax, if they don't know the syntax. And it's a good thing for them to just know in general, like to be able to do that. Now we'll get into defining a constant. So we can define this one. Obviously, you can see that it's equal to 2, and then you get an error here. So this word is protected because it has meaning within the mathematical language. So like constant actually means something. And if you could see here, like for cosine, you can't use cosine as like a constant or a variable just because Mathematica already has it built in. And then the built-in functions are capitalized. It's just like a side note. So if one of the functions like sine, cosine, tangent, log isn't working for the students, they just need to capitalize it maybe. So and then we'll look at the double equal sign here. So also I'm doing shift enter to like evaluate the cell. I don't know if that needs to be said, but the double equal sign is basically just says like it checks equivalence. And we'll see that used in a function later on too, but so we should have gotten true for the first one and then false for the second one, just because we defined constant as equaling 2. Some basic function ideas. This is like the syntax that we'll be looking at. The incorrect ones are kind of just like typical things students might do. So as you can see here, this one's like green, the first one, because the syntax is correct. So that's a really good way to check. And then you'll get an output when you put in a number like that. So you have the square brackets, the underscore, the colon equals, and then the function. So then you have this incorrect one, and you can see that it won't work. This is just missing that underscore. This is very typical for students to do this when they're defining functions. Another incorrect one is using like the double equal sign. So that shouldn't work. And then this one is, they're changing the variable throughout. So like sometimes they'll define the variable as like t here, and then they'll be used to putting in x, so they'll put in x. I think that's good for that. Then deleting sections. So you basically just, this is just nice to know how to do, and like if their file's kind of crazy looking, like it's nice to simplify it, make it look good. So you click on the, I don't know if you guys can see that right there, and then you just press like the delete key and not the backspace key. I don't think that would work. Now this is my favorite part because there's so much going on with Mathematica memory. So Just kind of going over the basics of memory first. Be careful to not overuse a variable or function letter, just because Mathematica will store it, like it will keep it stored even if you delete the function or something off of the page. And it's often a good idea to encourage students to use many different letters or names for functions and variables, not just like F, G, and H for the functions. So, and also just avoid using X like altogether because you use X so much in the functions. So students will often just like copy or copy and paste from the example files they're given. So they might have like a lot of F functions. So just make sure that they're aware of that. And that might be why things aren't working. Because it could work at first if you're doing like plots, if you enter in a function and then you plot it, it could work at first. And then you like, if you define a variable further down with that same like name or whatever, or another function, then if you have to go back and reevaluate that plot, it will get confused because you've like assigned it twice, which is kind of weird. And that's why this is definitely something worth mentioning. So yeah, it's pretty confusing and it doesn't work like a lot of other programs we're used to. And it stores variables in really different ways that just isn't typical. So clear is a really good thing to get acquainted with. As you can see, there's nothing saved for A, so that's blue. And then when it's defined, it will turn black. So we'll press Shift Enter, and you can see that for all the A's, they've turned black. And then if you try to do this, you get an error. Obviously, we've already defined A. If you clear that, and then it's blue again, enter in the function, plot it, you'll get it. One really weird thing is like, if, say I clear it, and then I enter in the function, and then I enter in this variable, and then I try to plot it, it doesn't give you an error. It just like doesn't plot it, which is super confusing for students. And it's obviously confusing for us when we look at it to see that. And like, even especially if we're not seeing a variable that's like way further down on the page or way further up, like we're like, I have no idea why that's not working. Your syntax is correct. But basically, there's just a lot of importance in like order too. So it doesn't just evaluate from top to bottom like we're used to, but rather from like what's been shift entered. And it can just be really weird with that. So using clear is really great, and like making sure it's just blue first before they enter it in. It can be a really great way to troubleshoot that. Oops. So now it should work. And then quitting the kernel, basically, so it removes all locally stored data, including functions, plots, and variables you've defined. So we can kind of just see an example of this. Oops. So you can see all of that work, and they're all kind of defined by each other. Let's see. So I think this is more just for like a troubleshooting type of thing. Like usually you'd want to use clear, because if you do quit the kernel, which we'll do by going to evaluation, quit kernel, local, then you press quit. As you can see, everything's blue again. It worked. It's just all the variables have been cleared. But yeah, like I said, you do want to be careful with that because, again, they've written their Mathematica so that it's probably messed up somewhere. So just making sure that like once you define a variable, or if you go in and like shift enter again, if something that should be blue isn't, kind of look at why. Now this is the part when I was like preparing for this that I was like, this is literally all we need to know. Like this is the most important part. So the kernel is shared throughout all open Mathematica notebooks. So each function that's shift entered in one notebook will be recognized by the other open notebooks. And this is kind of a big deal because if they're following alongside a professor and they're like shift entering like f of x equals this, whatever, and they go over to theirs and they're like, the syntax is exactly the same, then obviously like we're confused, they're confused, but maybe just explaining that, like they're basically the same notebook at that point. Like, so it's super confusing and it's not top to bottom. And I think like that's typically where the problems come from, because we're like, yeah, you are doing it right. Like you have every single thing correct on the page. So I'd say if you were to take away one thing from today, this is kind of the thing. This is typically what's confusing because usually you can see like syntax errors if you look at the information tab and stuff, but this is harder to see, especially because it's not like you're going to get an error because you have the function defined. It's not like a problem. It's just in a different notebook. But now we'll look over kind of like the basic stuff. This is kind of just what Kinney and Yang said would be on the, yeah, what's up?
I have a question. So if it's open in another notebook, do they need to close that notebook then, or you just?
Or like you could quit the kernel and then just like look at the notebook, but if there's like you defined it, it will like carry over. So I honestly would recommend to just tell students like whatever your professor has it named as, just don't use that at all because it's going to carry over. Like it might if you shift enter. So just like to avoid it completely, name it something really weird. Like I feel like in other coding classes, we're really encouraged to like name it specifically and stuff like that. But usually we just do like F of X. But they can name it specifically as long as Mathematica doesn't already have that saved. But I don't know if that like quitting the kernel is probably the best if they have everything like that. But I from the beginning would just be like, just try not to name them the same. But now it's not as exciting because I was so excited about that. I was like, this is the problem. But basically now we'll get into like basic syntax stuff. So graphing, that's what they'll look at. They'll do this a lot. So obviously shift enter. Okay, I don't know why I had the clear there. Maybe it's confusing it, but it should be good now. So the correct way to do it, if you want to see the correct way, this is another way. It's instead of like the information tab, you would have a question mark and then the function name that you're like trying to get the syntax for. So you just shift enter that. And it will just tell you a lot of like basic things about it. Otherwise, this will pop up too. And that's kind of what we looked at before. And then this should work. This one won't because there's that underscore in there. So we've already defined the function up here, and that's when you use the underscore. So if they have the underscore, like they've just copied and pasted like a function, that might cause issues, and it just won't show up. It won't like give you any reasoning behind it. It just won't appear. You can also do multiple functions. So basically this is where like the list will come in. You do the list of functions with the curly braces. And then you can put in like a function like this that we've already defined, or just like any sort of function. And you can see them displayed here. So tooltip, I feel like is a pretty useful thing that we don't typically like tell students to do. But basically when you hover over it, you can see, I guess, like what graph is being displayed, even if one is named. So basically if we are having memory issues, it might be nice to do that because you're like, oh, it's not displaying the right one. What is it actually displaying? Oh, that's the one that's on the professor's like notebook. So we should probably quit the kernel or clear stuff. It's also good to be able to know what function is what for a student if they aren't as familiar with like what certain functions might look like, or what they're supposed to look like if they're just like starting out in their math classes and stuff. So now we'll go to manipulate plot. Yeah. Did I miss any of them? Okay, this one, Kenny said would be a good idea to know. I know he really likes this one. But basically what makes it different is like you have the function, the plot function within manipulate, and you have like an A in there, and that's the thing that you'll be changing, or any variable that you haven't already defined. And then you have like the X range, and then this plot range will basically like lock in the Y values, or the Y axis. So it's like -15 to 15, so that as you like drag it on, you can actually see the difference that it's making. You do this. I don't know for sure if they use this, but yeah, Dr. Kinney said to put it in there. So linear occurrence. This one's pretty weird. So basically what it is, I think Yang said they use it in Calc 2, but you just have to make sure that there's like one specific part that they have to have, and I'm not even sure why you have to have it in there. But we'll shift enter. Basically, this is like a base case because it's like recursively defined. And you have to have this little middle thing in there. This is the part I'm not really sure why you have to have it in there. If someone knows, let me know. But you have to have that in there. So when you enter it, then you can finally put in this. It gives you the answer right away. So this is like, for this next one, it's exactly the same syntax. Obviously, there's the C, except it doesn't have this middle part. So that base case, you enter it in, it enters in just fine. Then when you try to evaluate it, you can see that it's like black over here, which basically means it's taking forever. And in this case, we'll need to abort it, just if it's taking forever. And you get there by going to evaluation on the top and then abort evaluation. And that will, and usually if students can, like sometimes students think you have to shut down the whole notebook, but you don't. So finding derivatives, we can define this function. There's two different ways to do that. Also, let me know if you have questions too. Anything's weird. Usually you can use like apostrophes. You should get it. Otherwise, you can do the function that's like capital D in the brackets, and you should get the same thing. Essentially, what this number is over here is like the number of apostrophes you would have, kind of. But yeah, you should get the same thing. Students will probably use the first method because it's kind of similar to the syntax they use when they write it on paper and stuff. So I'm sure that's what will work. But if it doesn't work, like we know that there's another option out there. Finding integrals, another like basic thing. So we can get to this by going on palettes and then like classroom assistant and you go to advanced to get there. And this is how you can find a lot of like other symbols too. As you'll see in limits, we will need this arrow. So yeah, that's just a good way to get there. And then should get the log. Remind them that log is natural log too, because I feel like I remember being confused by that. But there are a few missing pieces when it comes to integrals. So Mathematica assumes that x is a complex number, so it doesn't include the absolute value bars on the integral of 1 over x, which is just wrong. So just reminding them like that that's actually what it should be. And then also remind students that there should be a plus C, but Mathematica won't show that. And I think, have they taken their gateway? Okay, well then, yeah, this is good because like it reinforces that you need that. If you say like, oh, just remember like it should be a plus C, or if they need to write it down somewhere, but it's also just a good thing for them to know. And then if this integral function isn't working, you can try using parentheses because sometimes it's like it's written like how they write it on paper or something like that, but it just will give you an error. But using parentheses will work. And then definite integrals, pretty much the same thing. Like you go to the palettes, you go to advanced, and then there's these options for the integrals. And then this is like the range basically in here. So it lists off x and then the range. And as you can see, you get the same answers. So this one's kind of fun. So there's like, if you get an integral with a really weird answer, you can either do like n and then like the answer that you've gotten, or n integrate, and you'll get the same thing. And obviously this is like much easier to interpret, even like for us, like just to this kind of, I don't know what this means. So also another thing we can do, which is kind of cool, is like, as you can see, when you get the output, there's like this little bar below it. And you can press like numerical value, and that's how I got that n function. And then obviously like that's, wow, this is looking weird now, but yeah, so it's nice to know that you can do that too. And there's like other things you can do, set precision. So I think that would just be like how many decimal places you want. Just stuff like that is nice to be aware of, especially if they're having trouble, like they have no idea what this means, which I don't blame them. So. And then actually solving equations. So this is the syntax for it. This is where like the double equal sign is used. So it's like testing equivalence kind of. Makes sense. It's what we expect from that. So you put in the function here, the variable that you're solving for. Here's the syntax for nsolve. So we'll see what it looks like in solve first. Obviously, again, you don't really know how to interpret that. Also, I don't know why I chose that number, but this is easier to interpret. Obviously, you can see there's like a complex number in there, but obviously easier to interpret than like this one. And then we'll look at find root too, because there are like some instances where solve and nsolve just won't work, basically just because it's like a program written, and there are some times where it just like won't give you an answer, or it will take forever, you have to abort it. So find root is another like viable option for that. So it's kind of similar syntax. It's the equation, but then you have to do a list of the variable that you use and like the starting point. So then, yep, notice how there's only one answer. Obviously, that's incorrect. And hopefully if they see something like squared, they should be able to identify there should be more than one. But the find root function finds one answer according to the initial starting point. So if we change the starting point from 1 to -1, we get the other root that we're supposed to. So just being aware of that. But I would say encourage them to use solve first, because they should get all of them. But if it's not working, that's when you should use find root. But it is always good to know like different ways to do things. So dsolve is used to solve differential equations. So make sure you don't have the y function or like any y variable defined before you do this, because it will get confused, and I can show you what that would look like. Maybe I shouldn't have. Like, so yeah, it doesn't know how to deal with that if you've already like solved for the function. And this, like I said, like the memory is really weird, so it could have been anywhere else in the notebook if you've already like defined it. Yeah. So then if I cleared y, it should work also. Then solving an equation with a boundary condition. So the only thing that really changes with this syntax is you have like that boundary condition in there, and that's kind of in like a little list area with the curly braces. But yeah, that's all that changes for that syntax. And then, oh man, it's because of the y. 1 second. What if this didn't work? That'd be horrible. It does. Okay. So you can see here, there's like a C1, which is what you'll look for if there's not a boundary condition, and then you can't see that in there because you have the boundary condition. So that's great. So with limits, it's kind of straightforward what you want to see. Infinity is another one of those things that's like like already in the program of Mathematica if you have that capital I. Otherwise, we can go to like palettes and find it. Same with this arrow. But another way to do this arrow, I don't know if this is great, but would just be to do this, and it should just automatically go there. It should do the same thing. But yeah, this is just the syntax for limits that they'll be using. Sums, another one, pretty simple. Basically, it's just found in palettes too. And then matrices can get kind of weird. So if we enter in these two, the multiplication is weird because you need a period and not like the traditional multiplication symbol. And then it will like look like that even if you have it in matrix form. And to get this form also, you can go into palettes and stuff. But if you put it in the function matrix form, you'll get that. And then another way to do this too, if you look at like use as a matrix in this bar and then display as matrix, that's how you get that matrix form. You can also do like other really cool things like matrix plot, which will give you that. I'm not sure if they'll need to do that, but it's nice to know. And then you can enter in these. So like a matrix, if you enter it in like this and you don't use the palette, you can get it in the matrix form like that. So now just for some final comments, the two biggest issues are like bad syntax, obviously, which we can use the information button for. And then it's a good idea to save this file and remind yourself of some of the common mistakes that students usually make. And then another way, obviously, to look at bad syntax would be with the question mark and then like the function name. And then another big issue, the memory. So encourage students to not overdefine symbols, maybe use a different symbol from what the professor uses if they're going to follow along with the example. And then utilize clear and quitting the kernel when you need to. I would say like more go towards clear, and then like, because quitting the kernel, they could just run into the same problem if they start defining it. But also noting that the order of shift, it's in order of shift enter and not just top to bottom or like bottom to top. Like it doesn't really matter. It's just in the order of when you shift enter it. And then always remind students to save their work, because I've definitely had Mathematica crash on me before. So using like Control S would be great. And then also, as you can see, there's like the little asterisk up here that will go away when it's saved. So if I do like Control S, that will go away. So that's like a good way to tell that it's saved. And then if the file is loading weird or like everything else won't work, we've tried a lot of different things, just have the student save the file and reopen it. And sometimes that could work. But that's all I had. So you guys can go. Is there any questions or like anything that was weird?